Hey class, welcome to Unit 5. Today we're going to look at the rational roots theorem and the fundamental theorem of algebra. This kind of goes right along with Unit 4 and what we have been learning, but it just kind of goes a little bit more in depth. So our goal today is to find the rational roots and apply the fundamental theorem of algebra. So first, the rational root theorem. The rational root theorem tells us all of the possible roots. So all of the possible solutions to the polynomial. So what you do is the solutions are all the factors of the constant term divided by all the factors of the leading coefficient. So let me show you how that works. So here, P is going to be our negative 24. Oops. That's our constant term. And then our Q is going to be our leading coefficient. So our factors of our constant, so factors of negative 24. You can multiply to get to 24 by taking 1 times 24, or negative 1 and negative 24. So it's actually positive 1 and negative 1, positive 24, negative 24. Or you can get 24 by 2 and 12, so positive 2 and negative 2 and positive 2 and negative 12. And you can get 24 with 3 and 8 and 4 and 6. So I'm just going to rewrite this because I kind of ran out of room. So it would be positive or negative 1, positive negative 2, positive negative 3, positive or negative 4, positive negative 6, positive or negative 8, positive or negative 12, and positive or negative 24. So 24 actually has quite a few factors there. And then divided by the factors of Q. So Q, the only way to get 3 is 1 times 3. So the factors of Q are 1 and 3. And it's all the possible factors of P divided by Q. So first, if I divide all the top numbers divided by the 1, you're going to get all the possible factors are going to be positive and negative 1, positive and negative 2, positive and negative 3, 4, 6, 8, 12, and 24. That's all the p's divided by 1. And then divide the p's divided by 3. So 1/3, 1 divided by 3 is going to give me 1/3 is a possible root. 2/3 is a possible root. Now 3 divided by 3 is 1. I've already listed that. And then I have 4/3. That's a possible root. 6 over 3 is the same thing as 2. It's already been listed, so I don't need to rewrite that. And then 8 divided by 3 would be 8/3. That's a possible root as well. 12/3 is 4. That's already been listed. And 24/3 is 8, already been listed. So all of these are my possible factors. So those are all my possible answers for this particular problem. Now, not every polynomial has this large of a list. Usually we find the possible roots to help us narrow down what the actual roots could be. That's how to find all of the possible answers. So the fundamental theorem of algebra, and we've talked about this before, just not as formally, it says that if f of x is a polynomial with degree of n, then the polynomial has n number of roots. So here we have a quadratic trinomial. So it's a degree of 2, which means that it would have 2 roots or 2 solutions. So the degree, the highest exponent, the fundamental theorem says, if it's nth degree, it has nth roots. The next one is a 5th degree polynomial. So 5th degree means that it would have 5 roots. All right, in our next example, we're going to find all of the zeros to this polynomial. It is cubic, which means it's going to have 3 roots. Cubic polynomial. List all the possible rational roots. So our p this time is 15 and q this time is 1. So all the possible factors of 15 would be 1 and 15, 3 and 5. So all of the possible roots of 15 would be positive or negative 1, positive negative 3, positive and negative 5, positive and negative 15. And then Q is 1, so plus or minus 1. It makes it easy. All of our possible roots divided by 1, this would just be the top numbers. So then let's use a calculator to narrow down. So I have 8 choices, 1, 3, 5, or 15, or the negatives. That would be possible rational roots. So rational roots, remember, are the non-repeating, the real roots, the whole numbers, like rational, either fractions or decimals that can be written as a fraction. So if you go ahead and use your calculator, decimals I think works the best for graphing. So that's what I'm going to use. I'm going to go ahead and plug this in. So y equals x to the third power plus x squared minus x plus 15. And if I can kind of zoom out here, you can see this is my cubic function. See the end behavior, it's positive. It has that positive slope. As you go to the right, it increases. To the left, it decreases. We have one root right here where it crosses the x-axis. Those are our real solutions, our roots, our x-intercepts. That's what we're looking for here. So that is at -3, which is one of our possible roots. So now I'm going to use synthetic division and then factor quadratic formula from there to find the other roots. So the first thing I'm going to do is plug in -3 into the function for synthetic division. So just like we did in the very last section of Unit 4. So I have 1, 1, -1, and 15 for my coefficients. So drop mamas, drop it down, then multiply. -3 times 1 is -3. 1 plus -3 is -2. -3 times -2 is 6. -1 plus 6 is 5. -3 times 5 is -15. And we get a remainder of 0, which means that, in fact, -3 is one of our solutions. So x equals -3 is one answer. It started as a cubic polynomial, which means that when we synthetically divide by an x, we're down to a quadratic now. So this is 1x squared minus 2x plus 5. And then we want to solve for x here. So I always see if I can factor it first. So it has to multiply up to 5 and add up to -2. I guess the only way to get 5 is 1 and 5, so there's no way I can make -2 with that. So unfortunately, it does not factor. We could use the quadratic formula then to solve, or this one would work nicely for complete the square since b is even and a is equal to 1. So any of those methods would work. Let's just stick to 1, the quadratic formula. So I'm going to use 1 for a, -2 is b, and 5 is c. So it's going to be x equals -b, so -2 plus or minus b squared minus 4 times a times c all over 2 times a. So it's going to be 2 plus or minus the square root. Inside here, -2 squared is going to be 4, and then -4 times 1 is -4 times 5 is 20. So it'll be -16 over 2. So the square root of -16 is going to be 4i. So it's going to be 2 plus or minus 4i over 2, which can be reduced to 1 plus or minus 2i. So then our other two answers are 1 plus 2i and 1 minus 2i. So I knew that there would be imaginary solutions too. If I look at the graph, it only crosses the x-axis one time, which means it only has one real solution. And then the other two solutions have to be imaginary because it does have to have 3 solutions. Okay, so we have a cubic function again. The possible roots here we have our p and our q. Factors of p, so the last constant term, factors of 5 is 1 and 5. and factors of the leading coefficient of 2 is 1 and 2. So all my possible roots are going to be 1 and 5, and then 1/2 if I divide. So first I divided by 1, 1 divided by 1, 5 divided by 1, and then divide by 2, and I get 1/2, and then 5/2. So those are my 8 possible roots. So then I'm going to use my calculator again. So I'm going to delete that one and plug this in. So y equals 2x to the third minus 5x squared minus 2x plus 5. Oops, I don't want an equal there. Okay, this one, it looks like I have all 3 of my solutions given to me. So we can use the graph to shorten the list of possible zeros. This one has 3 real solutions, and I know it's a cubic function, and so I don't have to do any more solving. My solutions are all given to me here. I have x equals -1, which was a possible solution. X equals +1, which was also a possible solution. And my last solution was the 5/2, which is 2.5. So those are my 3 answers. I know that it's a cubic. It has to have 3 answers. I'm given all 3 with my graph. So this one has 3 real solutions, which means there's no imaginary solutions. So then you're done for that problem. So sometimes you can use the graph to find all the solutions. Okay, my possible solutions are going to be all the factors of 12 over 1. So my possible solutions basically are all the factors of 12. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now we use the graph to help us because we could do synthetic division. There's 2, 4, 6, 8, 10, 12 choices. So without a graphing calculator, you could try every value here of the possible solutions until you find one that works, until you get a remainder of 0, and then that would tell you that it was an actual answer. So the calculator is nice because it helps us decide then what are, instead of possible, what are an actual solution. It gives us a place to start. So if we plug this in, y equals x to the 4th minus 3x cubed plus 6x squared minus 2x minus 12. So this is a quartic function. So we're going to need 4 solutions. It looks like it gives us 2 of the 4. It crosses the x-axis twice. I know that this quartic, it's even. It's going to have end behavior that goes up and up, positive. So even if I zoom out, I know that it's going to continue to increase infinitely. So I know it's not going to turn and come back down. So I have 2 answers here, x equals -1 and x equals 2. So using the calculator really helps me shorten up those lists instead of having to guess and check all of the possible solutions with synthetic division. So instead, I'm going to start with one of these. So I'm going to just start by plugging in -1. And I'm going to take my coefficients. So 1, -3, 6, -2, and -12. So 1, -3, 6, -2, and -12. And I'm going to do synthetic division. So drop down the 1, multiply, add, multiply, add, multiply, add, multiply, add. Ideally, you should get 0 if it is truly a solution, which our graph tells us it is. This was a quartic function, so now I'm going to end up with a cubic function here. So this is going to be x cubed, x squared, x, and my constant. So I have 1x cubed minus 4x squared plus 10x minus 12. Now, sometimes you're able to, when you get it down to this point, you're able to factor by grouping and finish solving it by that. Unfortunately, this one is not going to be able to factor by grouping. But I do have another solution, x equals 2. So I'm going to take this and plug it in again. So I'm going to take the new coefficients. So the 1, hold on, I'm going to plug in the 2 though, and I'm going to take the new coefficients. So the 1, the -4, the 10, and the -12. And I'm going to apply synthetic division one more time with the 2, with the other answer. So 2 times 1 is 2. Add, multiply, add, multiply, and we get down to a quadratic now. So this was a cubic. I went and divided it by one more x, so this is going to be a quadratic. So it's going to be x squared minus 2x plus 6 equals 0. And then, can we factor it now? I don't think so, because our other answers, nothing multiplies to 6 and adds up to -2. And I also know I can't factor it since my other answers are essentially imaginary. So you have to use the quadratic formula or complete the square. So if I continue with the quadratic formula, it's going to be x equals -2 again, plus or minus the square root, -2 squared minus 4 times 1 times 6, all over 2 times 1. It would be 2 plus or minus the square root, be 4, -2 squared is 4, minus 24, it's going to be -20, all over 2. So let's see if I can break that down. It's 4 times 5, which is 2 times 2, so I can pull out a 2. And it's going to be imaginary since it's negative, so it'd be 2 plus or minus 2i square roots of 5 all over 2, which can reduce one more time, divide all by 2, 1 plus or minus 1i square roots of 5. Okay, so I had all 4 of my answers here. It was -1, 2, and then 1 plus or minus 1i square roots of 5 are my last 2 answers. So there I had 2 real solutions and 2 imaginary solutions, but 4 total solutions because it was a quartic function. All right, I feel like this video has gotten rather long, so I'm going to skip the last example. Hopefully that was enough for you to catch on. Otherwise, let's get together and we can talk about it more.